involve building a block. So I'm going to go to more blocks, and I'm going to make a new block. Let's ignore the command tree, which is a block that I've been using to demonstrate, but let's take advantage of the back one. The back block is a block whose definition is over here where I'm showing you. It basically says put the pen down, turn 180 degrees, move forward, and then turn around. So it does the equivalent of what you would want when you say go back 33 steps or go back 200 steps. We're going to build a new block, and we will call it branch. And branch is going to have an option of one numerical input. So it's going to be branch of a certain number. And as you know, I can call that whatever I want, so I'm going to call it X. We're going to now build our program for the branch. It's going to involve moving forward a certain number of steps. How many steps? We're going to move forward. Sorry, I messed up with where I made the variable. We're going to move forward X number of steps, where X is from here, because it's part of the subvariable of branch. It has nothing to do with this. This is a mistake, right? Either done on purpose by me, which is not true, right? But by accident. You don't want to have another variable X. You just want to use the variable X that's part of branch. So we're going to move forward a certain number of steps. We're then going to turn, 90 degrees, 45 degrees to the left. So we want to make that turn right over there. And that means it's going to be facing northwest. And then we want to make it go forward, turn 45, and go forward again. So we're going to say move steps, but we'd like each half up top to be a fraction of the original one. So for now, I'm going to make it x over 2, so I need the green operator, right? But later we could use a multiplier to give us more flexibility. So we're going to say x, whoops, messed up, sorry, x divided by 2. So branch so far goes forward, turns 45 degrees to the left, moves half of what the base was, and now we have to go back. So we're going forward, so now we have to back up to finish and come back to that juncture where we can draw the branch that goes to the upper right. So I'm going to then use the back command, and I'm going to go back x divided by 2. I will try to show you so far what we've done. There's no question about it. I've taught this topic many times. This is hard. This is a hard thing to understand. And so therefore I've got to do the best quality of explanation with lots and lots of slowing down and examples. So far, branch moves forward, turns 45 degrees, moves half of its length, and comes back. If I can do this right on a new backdrop, I will get a new backdrop. And so this is what it's doing. What it's doing right now, if I could paint this, is it's going forward. Let's say I say branch of size 100. So it goes forward 100 pixels. You see it going forward. It turns 45 degrees. That means it faces northwest. And now it goes half of what it did before. So that means 50. It then backs up using the backup thing, retracing its step, and that's where we are so far. What's the next two steps? See if you can answer before I do. It's facing this way, so we have to make a turn. Then we have to make this one over here. Let's go back to our sprite, and let's go back to our script, and let's see if you got it right. We have to turn 90 degrees, not 45, 90 degrees, so that we face northeast. So I'm going to move x over 2 now, facing northeast. And I always got to remind myself, it's this variable inside branch that I'm using, or it would be a mess if I did what I did before and tried to have a new variable x. This x is a local variable that came for free when I made the block called branch. So we move forward, we turn 45 degrees to the left, we move half, we come back that same amount. I think we need to rotate here. I think we need to turn 90 degrees. Turn 90 degrees so we're facing northeast. I thought I did it, but I didn't. Now we move in that direction, and now we're going to go back in that direction. We're almost done. So you got to try to understand this, and I hope this is not too painful, but it definitely is hard. And it takes rewinding this video and trying it out, and this is a tough one. There's no question about it. So now we're going back. I need my block again. You see a little symmetry here, and hopefully you're following what I'm doing. So far, I'm not going to have anything resembling a tree, right? But I'm not that far away from it. I'm going to have a capital Y, a variable size. I probably could have done something better than this because I keep messing up. Okay, let's put the word branch of size 50 at the main program under the green flag and give it a shot. So this is going to be a branch of size 50. Cross my fingers and click on green, and here we go. It did it. There's my capital Y. I'll do a branch of size 100. Green flag. A bigger capital Y. And each capital Y is really one branch and two baby branches. And the one branch that was drawn is the move, and then the next branch, the first baby branch, is right here, move and back, and the next baby branch is right over there. Now, things are about to get complicated, and it's real important that we leave the cursor where it started before we drew the capital Y. So I'm going to have to demagnify, zoom out a bit, give myself more room, and finish this off by turning 90 degrees, not 90, turning 45, right? Because we need to turn 45 right over here. And that's going to make it face north exactly. And then we have to do the opposite of that original move. We have to say back X. You got to put the capital Y so it draws it and returns it to where it started. So now I'm going to add the command back X steps. So I'm going to get back, and I get the X. If you're thinking of partners, this move command up top, right, the very first one, is partners with the back where it retraces its step. The move X over 2 is the one facing northwest with the back one. This is the one facing northeast. The only difference now, if I run the program, is it returns to where it started. So here's the idea, the powerful idea. What if I interrupted it at the end of the northwest tip? That would mean right over here. That would mean, what if I said, hey, at that point, do a branch of half, or whatever percentage I want, do a branch of x over 2 in the middle of doing the original branch. So let me get the x over 2. X. How many times are you going to see me make the same mistake? Sorry. X over 2. Right there. Now, what's going to happen when I run this program? Try to be the judge. I'm going to yell out branch 100. And so it's going to do a branch 100. But in the middle of doing a branch 100, it's going to do a branch of 50. Because that's what this line is, right over here. Will it ever get down here? No, it'll never finish this. It's like the Larry Bird doll and telling him to jump, lie down, and then he says a number and he does half of that. He never gets to finish it. We need an if-then statement. Without an if-then statement, here's what we're going to get. It gets stuck at the very smallest branch and never ever stops. I'll stop it with the stop sign. What I need is an if-then statement. An if-then statement that says, if something is true, then stop, but not stop everything. So if x is really small, and you can define and decide as programmer what really small is. So if the value of x is maybe less than 5, then stop. But like saying to a student, stop, because a student is messing around, that student doesn't stop breathing, doesn't stop smiling. What does stop mean? Right? Not stop everything, not stop your lungs. No, just stop this one script. Because the branch 100 calls a branch 50, which calls a branch 25. When it gets real small, it stops that one, and then it continues and resumes. And this is the power of recursion. Let me run it. There's still one major bug. I hope you know what it is, because I have drawn the left branch, the northwest branch, but I never drew the right one. So it's not going to look like a symmetric tree. Okay, it's not doing anything. Branch 100. If x is less than 5, then stop this script. So, what do we have? Where's the bug? Oh, we never did the right one. We never did the right limb of the tree, the one that was supposed to be northeast. We have move x over 2 and branch x over 2. So the branch happens right after that move. So right over here, after that move, we need to put another branch in. And that again is going to be branch x over 2, choosing the x out of the block. And watch how we're getting a better fractal now. When I run the program, it draws the left side and it draws the right side. And you have your whole series of uppercase Y's, capital Y's, going level 1, 2, 3, 4. And the density of these things is related to the dividing by 2. That's what's making it have a branch of a certain amount. If I divided it by something smaller, if I divided this by 1.3, and each one of these was 1.3, and I could always use a multiplier instead. This only takes a second, but I probably could have done this with a variable. Can you predict what's going to happen? Each branch is not going to be half of it, but when you divide by 1.3, it's almost the original one, right? If something is 50 and you divide it by 1.3, it's not 25, it's closer to, 50 divided by 1.3 is closer to 40. So when I run it now, it does so many levels of branching that it's going over the edges, and we know what happens when Scratch goes over the edges. So to compensate here, I better say if x is less than 10, and maybe that would give me a better fractal. Still bad. How about x is less than 20? You get a sense, but it's not really what we want. But probably we could solve this by going a branch of size 50. There we go. Now each y is like 70 or 80 or 85% of the previous y, and so you have a different density of the fractals. Now I hope this helps, and this is lesson 8.1, and this is the whole program. The whole program is right here. And whenever you learn something hard in math or science or literature or history, you have to study it and then put it away for 12 hours, 24 hours, or 6 hours, and then come back to it and see if you can recreate it. So I challenge you to study this, put it away, don't look at it tomorrow, and see if you can recreate it. And it doesn't have to be a capital Y. You can make fractals with a capital H. The key idea of the fractal is that at some point in drawing, it does the same thing again at a smaller percentage. And that's where Wikipedia used the word self-similar. So it's drawing a smaller branch in the middle of drawing the big branch. Okay? This is Steve Bergen signing off. Good luck with understanding and having fun and being creative with fractals. Bye, everybody.